So we develop devices that can create electricity from the heat of the sun. And unlike solar panels, we are more efficient than them. We can produce thrice as much electricity as solar panels. These similar devices can just connect with each other. So we can just connect like multiple devices together like Legos to build like very large array and then just take out power directly from like one plug. I wanted to build something that even people in my hometown could use, is as cheap and can still be as efficient. What our device can do, this one right now, can produce 400 watts per every single meter. What we are hoping that our device in the final version could do is produce 670 watts in that single meter. So right now we're in the process of filing those patents, and we'll hopefully soon be granted these patents.
Hello, everyone. We're Seinosuke and
Kana, researchers from karakuriLABS. Today, we're excited to speak with Mr. Sparsh, the CEO of student startup Incy Tech.
let's welcome him now. Thank you for joining us.
Thank you.
Okay, so we're gonna begin with the questions. So to begin, could you please introduce yourself? What is your name and what role you play in the company?
Sure. Hi everyone, I'm Sparsh. I'm the CEO at Incy Tech, a student startup here at National University of Singapore. And what we do at the company is we develop a version of solar panels. So we develop devices that can create electricity from the heat of the sun. And unlike solar panels, we are more efficient than them. Yeah.
Thank you very much. So next, could you briefly explain what Incy Tech is working on right now?
Sure. So we make these devices called thermal floaters. These devices can actually create electricity from the heat of the sun. And what these devices do is concentrate the sun's heat like a magnifying glass. And when you concentrate the sun's heat using a magnifying glass, it creates a lot of intense heat. And we convert that intense heat into electricity. And while converting that heat to electricity, we can produce thrice as much electricity as solar panels. So we are way more efficient than solar panels, and these devices can just float on any water body. And while floating, these devices uh, can connect to each other very easily. I can actually show you the device if you'd be interested in. Okay,
Yeah,
give me just a second. I'll just get you the device.
thank you very much.
Thank you.
So this is what we build. This
Oh.
is called a thermal floater. So what it does is takes the sunlight in from the top. On the top, there's a lens, and this lens captures all the sunlight and concentrates it at a very small point, creating a lot of heat. And then this entire contraption just keeps floating on water. It has sort of ports on the side, which can be used to take out electricity. And these similar devices can just connect with each other. So you can just connect like multiple devices together like Legos to build like very large array and then just take out power directly from like one plug. Yeah.
Thank you. Awesome. So could you explain what inspired you to start this project, please?
Sure. I'm actually not from Singapore, I'm from India, and where I'm from in India, in my hometown, we face a lot of power blackouts. We face a lot of power shortages. And when I started around 4 years ago, uh, our town faced a week-long blackout. And with a week-long blackout, with no access to internet, no access to electricity, I was scrambling my mind in the hot summer. How can I avoid this problem in the future? And that's when I thought of I should look forward to making use of renewables to power my hometown. But then when I asked the communities around me why they weren't using solar panels, they were like, "Hey, this is too expensive." So I wanted to build something that even people in my hometown could use, is as cheap and can still be as efficient. So that's when I got the idea of looking into renewable technology. And over the years, that idea has developed into the thermal floater.
Nice. So you started from a like personal experience and move up to helping a lot of people's problem.
Yeah.
Yeah, cool. Thank you. So the next question is, could you tell us about your co-founders and their backgrounds, if you have any?
Sure. So our team is small, but we have two co-founders. One of
Mhm.
them is Azan Qureshi. He's a he's a founding researcher working with us, and what he does is, let's say in a technology like this, how do we convert that heat into electricity? So what
Mhm.
Azan does is research on the more technical parts that
Mm.
actually matter. So he works with research labs in Singapore and in all over the world, in Taiwan, in Korea, and he works with those research labs, tries to figure out what the actual tech, how can we improve on the actual technology. And he's also a student from NUS, has a background in physics, theoretical physics, and works on that. Uh, our other co-founder is a prof. His name is Prof. Yushin. Uh, he is an he's a prof in the Department of Design Environment. Uh, he's also actually a PhD from MIT, so he has a lot of experience, a lot of technical experience, as well as he has founded startups before and has actually been like a venture capitalist. So he has a lot of experience in the startup founding side. So he guides us with the business, and that's more of our lead team. Other than that, we have a lot of members working with us, taking on roles, working on other critical components. Yeah,
Thank you.
Okay, so we'll move on to the question about more technological things.
sure.
So first, like, what exactly is a thermal floater and how does it generate electricity?
Okay. So, uh, on technical side, uh, it's easier to illustrate with a device. So, uh, as I said, the top part is used to just concentrate the heat, right? Concentrate the sunlight into heat. After it's concentrated, the heat reaches up to about 600 degrees, 600 degrees Celsius, which is a lot. And this bottom part, this entire huge chunk of sort of metal fins, stays underwater. So the top part stays over water, the bottom part stays underwater. And while the water is flowing through this bottom part, it cools it down a lot. So this bottom part stays at a constant under 50 degrees. What we do is utilize components that harness the temperature difference, that harnesses the temperature difference between the top side and the bottom side. So when there's a temperature difference of 600 degrees between the top side and bottom side, the electrons start to flow from the hotter side to the colder side. And what we do is harness that electron flow to convert it into electricity.
I see. So like what important is that is those difference between those degree is the
Yeah.
most important part of that.
Yes.
I
Yeah,
see.
so just the difference between the top side and the bottom side converts it into electricity, and we use diodes to capture that electron flow.
Ah, I see. Thank you. So, what is the difference between those, what is it, solar panels?
Hmm. So solar panels, what they do is just convert the light. So what happens is when light or photons come on the solar panels, they just knock off the electrons in the diodes uh, to the other side, and that causes electron flow, which leads to electricity generation. What we do is just not convert any light to electricity directly. We convert the heat to electricity. So happens when we convert heat is that we don't just use the potential from the heat from the sun. We also use some sort of energy from the water. So we have like a higher efficiency because we can use both the temperature difference from the sun and the water.
I see. So, how efficient is your prototype, and what are the expected improvements in commercial production?
Okay, so right now, this device can only generate about twice as much electricity as solar panels. So, just to give context, a solar panel can produce about 200 watts in a single meter. So, let's say if you fill a single meter with solar panels, it would only produce 200 watts. What our device can do, this one right now, can produce 400 watts per every single meter. What we are hoping that our device in the final version could do is produce 670 watts in that single meter. So it would have an energy density of 670 watts per meter square. And the total energy that comes from the sun is only 1,000 meter per every single 1,000 watts per every single meter. So our efficiency would be about 67% if you take just the incoming sunlight. But since it's a lot more complex and we just don't convert the incoming sunlight, we also convert the temperature from the water as well. So that's not direct comparison of efficiency, but if you just had to compare like a direct number to number, it would be about 67%.
I see. Thank you. So, so why did you become interested in those solar thermal generating system? Like, I guess there are other generating systems, but why did you get interested in that
Right.
methods?
Okay, so solar thermal is a very interesting scenario. Uh, I'd like to actually ask you a question. Do you know how heat gets converted into electricity in normal, like not in our device, just normally? Uh,
Mm,
Is
mm,
it
like,
like
okay,
more?
yeah, it's motors. So heat gets, what we do is, and for any type of heat, let's say we heat up coal, we burn coal in nuclear reactors, anywhere we have to convert heat to electricity, what we have to do is heat up water, water gets converted into steam, steam runs up a turbine, turbine
Yeah.
ramps a motor, motor creates electricity. In this huge process, we have so many inefficiencies,
Mm-hmm.
so many energy losses. And I honestly was just pissed that in like hundreds of years of human evolution, we haven't found a better way to shorten it down into just heat to electricity.
Yeah.
So that was my main goal of finding a way to shorten that heat to electricity transformation. And now what we can do is convert that heat to electricity directly in one step. And that's what I really wanted to achieve was shorten this entire energy efficiency losses into just one step and just improve on that.
Okay, thank you. Are there any intellectual properties or patents you filed or are planning to file?
Yeah, there are a lot of parts. So the actual part that converts this heat to electricity is called like a thermocouple. So we own the rights to the materials used in it, as well as these systems that we see, like this lens on top. This lens can actually concentrate about 7,000 times. So the best lens in the market can only concentrate up to 6,600 times. So our lens is more powerful than that. So we're patenting the designs for the lens and our other parts like the casings that allow these lenses to connect to each other. So right now we're in the process of filing those patents, and we'll hopefully soon be granted these patents.
Okay, thank you.
So next we're gonna move on to more business.